Hello, class, and today we'll be discussing the topic of Sir Isaac Newton and his three laws of motion. We will also be going over why it is important and the relevance of Sir Isaac Newton in today's society, even though he lived a long time ago. So to start it off, Sir Isaac Newton was born on January 4th, 1643 in England. Newton, he had a peculiar childhood being raised. He wasn't only just like a normal kid, mother and father, or just mother. Like in today's society, Newton was raised by his grandmother after his father had passed away, and his mother remarried, leaving the responsibility with his grandmother to raise him as she remarried and moved on with her life. But alongside from physics, as we know that Sir Isaac Newton was just amazing in, he made significant contributions to mathematics, particularly in calculus, optics, and astronomy. But that's just a little background information. His legacy will always be here. It's Sir Isaac Newton, like one of the most popular people in the mathematics world. But to get into his three laws of motion, Sir Isaac Newton's first law of motion is the law of inertia. And to explain it in a less classy way, a more formal way, a less formal way to explain the law of inertia is like, let's say if you're driving in a car, not you, but let's say if a person is in a car driving 60 miles per hour and hit a tree stump and the car comes to a complete and total stop. The car comes to a stop, but the person isn't coming to a stop. So said person will fly through the windshield because of the law of inertia, as we learned through Sir Isaac Newton text and different things that he left behind for us to study. So if a car is moving, the person's in the car, hits a tree stump, the person flies through the windshield. That's simply the law of inertia explained. But what it says is a body at rest will remain at rest. A body in motion will remain in motion. So that means, like I just said, let's say the car is going 50, 60 miles per hour and the tree brings the car to a complete stop. The person in the car didn't stop. Nothing stopped the person in the car. Maybe the seatbelt, but it said the person had the seatbelt on, then they'll fly through the windshield, causing the law of inertia to come into play. Newton's second law of motion is the law of acceleration. The law of acceleration is the force acting on an object is equal to the mass of that object. Time is accelerated. The equation for the law of acceleration is, in quotations, F equals ma, close quotations. For example, if you're pushing a shopping cart, the force you apply, the faster the shopping cart accelerates. The heavier the cart, which is like the greater the mass, requires more force to achieve the same acceleration as the lighter one. So for another example to help you understand what I mean, is like there's a truck and there's a car. They both have the same engine, but the car might seem just a little bit faster than the truck because the car is lighter. And let's say there's the same amount of weight being pushed down on the pedal, the car will always go faster than the truck because they have the same engine and the car is just lighter. So that's the best way I can explain the law of acceleration. If you want something to go faster, you have to put more force into it. And if it is heavier, then you have to put that much more force into it. Therefore, to make the heavier shopping cart or car or truck move faster. You understand? Okay, to get into this last law, Newton had three laws of motion that we use in our everyday life that we don't really, think about. Like we just learned about the second one with a shopping cart. I didn't even, as a regular person, not knowing, we wouldn't even think of that. We're just thinking we're pushing a shopping cart to the grocery store. But Newton's third law of motion is attraction-reaction law. For every action, there is an equal or opposite reaction. So for example, when you jump off a diving board, your feet push down on the diving board, and that's an action that the diving board bends, and the diving board pushes you upward with an equal force, which is the reaction, and it propels you into the air. So just like to explain that in more of a sense, like we just said, we just learned the diving board. When you push down into it, let's say if you weigh 150 pounds, then that diving board is going to take that 150 pounds and push it back into the bottom of your feet for you to be propelled into the air to land into the pool. That's pretty self-explanatory, but like, thinking about it, we would never, when we go to the pool, we don't go to the diving board and say, hey, Newton's law of motion is about to be in play. No, we just, live our everyday regular lives, not knowing that. The applications of Sir Isaac Newton laws, like you can apply it to different things in life, like the examples we just went over with the weight of a car or the weight of a shopping cart or the diving board, or if somebody is in a car moving fast and hit a tree stump. When a soccer ball is kicked, like let's say if you kick a soccer ball, this is to deal with the second law of motion. The force experimented by the leg accelerates the ball. So if I kick a soccer ball as hard as I can, then the ball will get equal force back onto the foot. Like, how do I explain that? I was just learning, in class as we learned. So if I kick a soccer ball with my foot is gonna still that same, like, if you kick a soccer ball as hard as you can, it's not that your foot isn't gonna feel anything. The soccer ball is gonna push force back off of your foot in order to fly, like the diving board. You see, that's the second and the third. That's the law of acceleration when you kick the ball. And then the third law, which is the law of action and reaction, is when the ball bounces off. Basically, it bounces off your foot and flings into the air, even though we don't see it literally bounce. But when you kick it, it, forces back out. So that's like a part of life where the third and the second law can come into play in one thing. Now, that's not the only way, but that's just a great example for you to understand and articulate how Newton's laws can come into play into your real life, everyday life. Like, every day these things are coming into play in your life. But just to talk more about, Newton's impact and value of laws in the community and in society today, Newton, like his laws are still very much relevant today as they were in the 17th century. They form a basis of classical mechanics, which governs how objects move under the influence of forces. These principles are applied in a variety of modern fields, including transportation, technology and engineering, everyday life, and space exploration. Now, mind you, I don't think anybody was thinking about going to space when Isaac Newton was alive and he made these laws. And now as we go to space, or NASA claims to have gone to space on different occasions, they still have to use the laws that Sir Isaac Newton made in the 17th century. We're in the 21st century. So you can just see how many centuries it's been. What was that, 4 centuries since these laws were created, and they're still being used today in everyday life. In the modern era, Newton's laws also form fundamental understanding for advanced theories like the different theories like quantum mechanics. Though quantum mechanics is like very hard to understand and explain, but that's like I just read it. Quantum mechanics came about nearly in the last decade or so. And to say that they're still based upon theories and principles that were made in the 17th century is very powerful. But thus, saying all of this, Newton's laws have an enduring influence, continuing to enable technological progress and underpinning our understanding for the physical world. It's like Sir Isaac Newton, I'm not going to say he changed anything, but he brought a new insight to the world that we know today, I can say. But thank you for your time, and I hope you enjoyed. If you have any questions, you can contact me on my email at 225nehemiah@gmail.com. That is 225nehemiah@gmail.com. Thank you.